Okay, so we're going to look at our example here for using technology with linear functions. So the table shows a monthly average water level of a North Texas lake over a 12-month period. So remember, when the table is sideways, the top row is X, the bottom row is Y. And we've got a scatter plot here that I've already put a scale on for you. So we're just going to go ahead and very quickly plot these out. And so I'm counting by twos, and I want to make note that I am skipping all the way up to 514. Okay, I don't want to scale up because if you look at your Y values, they're all pretty close together. Like the lowest is 514 and the highest is 523. So since I'm using a very small amount of Y values, but they're very high, I want to skip over all of those hundreds from 0 to 500. And then that is how we show that in math, that I don't need any of those Y values. I need to get to this set of Y values. That's where all my data is. So, and I'm counting by ones on the x-axis. So 1, and then this is 5, 16, 18, 20. 21 is going to fall halfway between 20 and 22. And then 2, 523 would be halfway between 522 and 524. And then 3, 522, that's right on the line, so that makes that nice. 4 and 519. So if this is 518, the next is 520, so 519 is going to be right in the middle. 5 and 516 is going to be here. 6 and 518 is here. 7 and 519 would be here. 8 and 518. 9 and 515 would be halfway between 514 and 516. 10 and 516 is here. And then I'm going to go ahead and add in 11 and 12. So 11 would be about right here, and then 12 and 14 would be right about here. So if you look at your data, it looks like it's kind of linear, and if I kind of estimate a line of best fit, that's kind of what it looks like, okay? So we made a scatter plot of the data, and here's what we're going to do now. We're going to use our calculator to get an equation from our calculator to fit this data. So we're going to figure out what the line of best fit is using our calculator. So we're going to go stat edit, stat enter, and we're going to type in our values. 6, 7, 8, 9. I'm going to include 11 and 12, and I'm going to go back so it's 521, and you want to make sure that you are typing in your data very accurately. I'm at 518, 519, 518, 515, 516, 514, 514. Okay, I would double check to make sure you typed in your data correctly, and so now we're going to go to stat, right arrow, and because it is a linear function, they told us it is linear, we want to pick option 4, and now we're going to arrow down and press calculate. All right, so A is equal to negative 0.74, and I'm going to make that a 5 because I'm going to round up. That 7 is going to make that 4 go up to a 5 for my A value. And so my B, which is my y-intercept, is 522.75, and I'm going to make that 8. I'm going to go ahead and round them to both to 3 places after the decimal, the thousandths place. And if I want to make an equation out of that, it's going to be y equals, my A is my slope, so negative 0.745x. And then my y-intercept is positive, so it's going to be plus 522.758. All right, and so now we're going to identify the correlation coefficient. So to do that, I have to go back to mode, and I'm going to arrow up. Oh no, I'm going to arrow down. You can arrow down or arrow up, whichever way is faster. And then you're looking for stat diagnostics, and you want to turn those on. And then you want to quit that screen, clear it off. And you're going to do the same thing again. We've already entered in our data, so we're just going to do the second part. So we're going to stat arrow over, we're going to press 4, and now when we calculate, it's going to tell us our R coefficient. R equals, and you want the bottom one. You don't want R squared, we just want R. Negative 0.8865. Okay, so now this R value, the correlation coefficient, is actually going to tell us 2 things. The sign is going to tell us one thing, and the number is going to tell us another. So what the sign is going to tell us, so the fact that we have a negative sign, that is telling us that we have a negative correlation And we should see that. What direction is our scatter plot trending? It's trending in the down direction, which matches the fact that our R coefficient is negative. So it's almost like it's telling you the direction. So it's telling us a downward direction. And then the number itself is telling us how strong or weak it is. Well, if I look at that number, I want it to be close to 1. So is 0.88 close to 1? And the answer is yes. So it is going to be considered a strong correlation. So this R value is telling us that our data is pretty close to being in a straight, being linear, being in a straight line, and its direction is negative. So it's going down, which matches up to what we see. My line of best fit, my scatter plot is pretty close to that line of best fit that I sketched in there before I found my calculator. And now we're going to predict. When they say predict, they are saying, hey, use your equation and you're going to go to y equals. So we're going to go to y equals. And we're going to type in our equation. We are going to type in negative 0.745x plus 522.758. And now if I want to make a prediction, that means they're either giving me an x or a y value, so I need to look at what they're giving me, and they have given me an x value. And I know it's an x value because months measures time. So they are telling me that x is equal to 15. So now I know I need to go to my table. If they're asking me for a specific x or y value, that means go to second graph. And now I'm going to scroll down to 15, 10, 11, 12, 13, 14, 15, and 511.58. So in 15 months, I'll write this in a sentence just like we did for exponentials. In 15 months, the water level should be 511.58. How are they measuring the water level? In feet. So we're going to say feet. And that wraps up Category 2 review.